So example number 4 wants us to construct a function given some information, given that dy dx is equal to tangent of x and f of 3 equals 5. So what we could do is we could go through, take the antiderivative, and then evaluate and figure out what c is, and because we know that the antiderivative has to pass through the point 3, 5, right? In other words, the 3, 5 is a point on the line of both the tangent line and the original curve. Or we could apply the Fundamental Theorem of Calculus, which tells us this, that y is equal to 3 to some value x. X could be arbitrarily bigger than 3. We could, if we want it to be. Tangent of t, dt. So now, if I take the derivative of both sides, it should be this. So we're going to kind of work backwards, right? If I can make this equal dx dt, then we can go through. So what I could do, I could say that f of x, applying the fundamental theorem of calculus, is equal to the integral from 3 to x of tangent of t dt, right? Now it doesn't matter what that value is. It doesn't matter what that value is. It should equal 5. So we tack on the plus 5. So now let me explain where that comes from. If we were to evaluate, so the fundamental theorem starts here, okay? This is the fundamental theorem of calculus, and we're going to build from there. And so I'm going to read exactly what your textbook says, and then I'll explain it in regular English. It says the fundamental theorem of calculus makes it easy to construct a function with this first step. Then it says since y of 3 equals 0, we only have to add 5 to this function. Well, what do they mean y of 0? Or y of 3 would equal 0. Well, remember that if I let x equal 3, right? If I let x equal 3, what they're saying is y of 3 would be evaluated at the integral from 3 to 3 of dt, of tangent of t and dt. Well, this is one of the properties, right? This, what's the area under the curve if I'm evaluating from 3 to 3, if it's b minus a, right? Well, the area under the curve for this thing is always 0. So what I'm saying is that f of 3 equals 0. If I leave it in that way. But f of 3 does not equal 0. F of 3 equals 5. So this right here equals 0, right? This from here to here that equals 0. So how do I make it equal 5? Well, it's simple. I just add 5 to it. That's just applying the properties. So it's very important that we memorize those properties. Okay? And that's it for part 1 of Fundamental Theorem of Calculus.